In this lesson, we are going to be completing page 98 and 99 and learning what formula weights and molar masses are and how to calculate them. We're going to start on page 98. So here is this handout that you should have and eventually get it glued onto 98. It says the title is formula weights, so that's one term we use, and it says you may see the following terms: formula mass, molecular mass, and molar mass. I would like you to highlight those just like I did. These terms all pretty much refer to the same thing in regards to doing calculations. So if you see any of those words and they ask you to calculate that, you're going to follow these directions. For now, we're going to refer to this concept as molar mass. This term is super important in doing lots of different calculations in chemistry. There are two things that you need to know. You need to know how to locate atomic masses on the periodic table and how to count up atoms and formulas. Alright, so for example, there's 6 carbon, there's 12 hydrogen, and 6 oxygen. The subscripted numbers written to the right of the letter are for that particular element. The middle of this and the bottom have examples. I'll zoom in on this particular example. If I do it, you do it. I'm going to find a smaller pen. Alright, it says, what is the molar mass of glucose? And they gave me a formula for that, so I will thank them. I have these particular columns that tell me what to do. We got atoms first, the number of each times the periodic table atomic mass equals a total number. So I'm going to list the elements. There's a carbon and a hydrogen and an oxygen in the formula for glucose, C6H12O6. Here it says number of each, so I'm going to take these subscripted numbers to the right and put them in next to the elements that they are for. And then I need to go to the periodic table and find the atomic masses. All atomic masses are equal to a mole. Right? Atomic mass is written on the bottom. So carbon is right here, 12.011. We don't need all of those numbers for us, so I'm just going to round to the hundredths place. That is plenty. Hydrogen is over here. In your periodic table says it's 1.008. I would like you to use that particular number in its entirety, please. And oxygen is right here, and it's 15,999. Please do not round oxygen up. I have to multiply these two. It's not a sig fig event. I'm just going to go 6 times 12.01 equals 7206. 12 times 1.008 is 12.096. And 6 times 1599 is 9594. Now for some reason this handout doesn't tell you you should add those together, so you might want to add a plus sign. I'm going to do 72.06 plus 12.096 plus 95.94. And I get 180.096, and that's grams per mole. Now, mole is written this way, and the abbreviation just drops the E because M is taken for meter already, and ml is taken for milliliter. So there you have it. We know how many grams would be in 1 mole of glucose. So if I wanted a mole of glucose, I would go to the container and I would weigh, or 180 grams of it, and then I would know I had 6.02 times 10 to the 23rd molecules. Do one more on this template, and then you're going to glue it into 98. What is the molar mass of sodium sulfate? Na2SO4. So again, we have a space for the atoms. I'm going to list Na, S, and O. And I need the number of each, so there's 2 sodiums, 1 sulfur, and 4 oxygens. The atomic masses from the periodic table, sodium's over here. It is a group 1 alkali metal. 22.99 is the atomic mass. 22.99. And sulfur is a nonmetal. 3206. 3206. And we already have oxygen from above. This one right here, the sulfur, is super simple. I don't even have to pick up my calculator. So that I don't forget to do this, I'm gonna just rewrite that over there real quick. 2 times 22.99 is 45.98, and 4 times 15.99 is 63.96. And you need to add these at the end. They did not show that to you. So 63.96 plus 3206 plus 45.98. I get 142, and that's grams per mole. So if I have this ionic compound or a salt of sodium sulfate and I need a mole of it, I would go and measure out 142 grams. Please take that and glue it into your notebook now to page 98. So close. Oh, there you go.